Hi, everybody. This is Matthew Poes of Poes Acoustics, and this one is how to calibrate Dolby DTS surround levels. And CycleCom asked me a question. He gave, looks like €5. Hey, thanks for the free advice here and on Audioholics. I mean, you paid me €5, so not totally free, but yeah, no problem. So I watched your video on tactile bass and the importance of having a floor that's easy to vibrate, which then transfers through your seating. However, I think there's an aspect you missed, which is the construction of the chair itself. I have a wooden floor, which very easily vibrates and can be felt underfoot. However, while our sofa gives amazing tactile feel, the chairs we have don't at all, even when turning the volume up way more. I have done a bunch of informal experimenting with various chairs and items around my house and with the stereo in the work break room and come to the conclusion that for the most tactile vibration, you want a chair that acts as close as possible to a membrane and/or porous acoustic panel. The chairs I found that don't vibrate are very solid and or have damping, e.g. a metal-framed office chair with pneumatic height adjustment, and the best are floppy and or cushioned, e.g. a cheap armchair or the flip-out plastic frame chairs they have at BFI IMAX, which seems to vibrate more than the bigger premium recliners. I think there may be some component of transfer through the air to the chair as well as the floor, even if it's less so. After all, the floor will vibrate even if the speakers aren't coupled to it, like yours, and you can feel, for example, if you hold up a piece of card or acoustic foam up to a speaker, it will vibrate a ton. This seems logical since they are designed to absorb sound energy and convert it to mechanical heat energy. Would you agree? I understand this isn't something with seemingly any hard research done on it, hence why I'm asking you, but any of just your thoughts or anecdotes from setting up or experiencing other people's systems would be appreciated. Well, so I appreciate the question. I don't know that I agree with everything you've said. So the porous absorber idea, I don't think is correct. That would actually not make a lot of sense to me, and if anything, would be causing a counter effect. So you're making the argument that the porous absorber is converting to mechanical heat energy, therefore it's vibrating you more. But think of it a little bit differently. If you're taking a finite amount of energy and you're converting it through the vibrations to heat, you're dissipating that energy, you're not transferring it to a person. So that would actually reduce the tactile effect, not increase it. However, there could be something to this for other reasons. You're saying very solid chairs that are well damped seem to not vibrate very well, and floppy chairs seem to vibrate a lot. I don't tend to put that range of chairs in theaters. I tend to only put in couches and everything's got cushioning kind of thing. I just don't have the experience with that. I've put an office chair in here and it vibrated fine, so I don't remember that. But it's hard to say, I guess. I think that there is, I could talk about this from a technical standpoint in generalities, but I don't know that I can give you specific answers because there's just so many variables that could be causing your experience. And we would want to isolate those variables and kind of come to some hard conclusions. So here's my general thoughts on this. If the chair basically takes the energy and then just converts it to movements that kind of dissipate out as heat and get absorbed in the mechanics of the chair itself, it makes sense that less of that then gets transferred to you. That's the whole concept of decoupling in the first place. And so certain chairs may be effectively better decoupled. I don't know that this is true, but the pneumatic mechanism on a chair may actually act like a shock absorber. So it's possible that that was absorbing some of the bass. I find cushioned chairs vibrate a lot. I don't have issues with that if the floor vibrates. I don't couple my chairs to the floor. I haven't put down flip-down chairs in a theater that I sat in and watched in a really long time, and I never really thought about it, and I don't remember in the very few times I've done it what happened. We've spec'd it in theaters, but I never went on site, so I never saw what happened when they finished the project. It was just a design basically that I handed off. So, and I don't know that they did it. They may have actually chosen not to. I mean, I guess, again, going back to the kind of the science of this, it's how much energy from the subwoofers can be transferred to your body in some way. So some of that energy gets transferred directly through the floor. We'll call that induction. And some of that energy gets transferred directly through the air. And I think that the energy that gets transferred through the air, some of it would hit the chair and transfer from the chair to you, and some of it would hit you and be transferred directly. In those scenarios where you've got like a concrete floor, most of, I think, the vibrations you feel is the air transfer, which is why it takes so many more subwoofers to get that vibration. And very little is through the concrete, because concrete's so massive, it's just hard to move. Doesn't mean there's no vibrations. You can still ripple concrete. It's just very subtle compared to plywood, for instance, or in my case, a sprung floor. So yes, I agree that some of the energy is being conducted through the air directly, but I'm not really sure how the chair's construction would affect that much, I guess. Trying to look at this and see if there's more things to say about it. Yeah, and I mean, sound, so when sound transfers through the floor, something to think about, if you've got subwoofers sitting on stands on the floor, some of the sound that transfers to the floor is through the air, that's correct, but the fact that it's physically attached to the floor at all, even if it's just sitting on top of it, is going to transfer sound energy. So my subwoofers are actually sitting on baker's racks in order to get them in the right location. Not an ideal setup, but they're sitting on baker's racks, and they're on the floor. On the baker's racks. And so some of the subwoofer's sound energy from looking at them, because you're wondering where I'm looking, some of that energy transfers from the subwoofers down the poles that make up the four corners of the baker's rack to the floor itself. There's a lot of decoupling and stuff going on there. So certainly there's other places the sound energy transfers through, but a lot of it is right through. I have theorized, but I've never actually bothered to do this, that if you were to physically couple a subwoofer to the floor, you would be transferring more sound energy. And that even with a decoupling device to help reduce mechanical vibrations, that might be a good thing. In the back of my room, I have two subwoofers which are mounted in the wall. That wall is coupled to the floor that's floating. The inner part of it is. The outer part is not. The subwoofer is mounted using, I'm going to call them double decoupled mounts. I'm calling them double decoupled mount because what I did was I used an L-shaped bracket with a rubber grommet, or it might have been silicone. And then I also used a hush frame bracket. And I combined them together. And actually the screws that we used to attach everything also had rubber grommets on them. And those were definitely rubber. So you might call it, triple. So the metal of the L bracket has some resilience to it. It's going to move. The rubber has obviously resilience to it. And the silicone has resilience to it. And so there's all these points of flexure. In theory, my thought was that was going to stop most of the sound energy that gets directly transferred to the wall. In practice, I think that the subwoofers produce so much output and vibrations that it didn't actually stop. It might have stopped most of it, I don't know, but I don't think it stopped all of it. And I think a lot of sound energy transfers through the wall, actually, anyway. I suspect, but I don't know because I have no easy way of testing this, that as a result, those subwoofers are transferring energy directly to the floor, and that some of the vibrations in my room may actually be a result of the direct coupling of the subwoofer to the floor in that mechanism I just described. I'd be curious, I can't do it in my room because I can't ruin the look of the room, but I'd be curious in a scenario where you could play around with that better, and I think RBH could do this. So I may ask them to do it since it was their subwoofers I used for this, to try taking those L brackets and using them to directly mount a subwoofer to a wooden baffle or something that wouldn't be a baffle, but like a wooden platform that the chair sits on, and test whether resting the subwoofer on it versus physically coupling it gives more tactile bass. Anyway, CycleComm, I apologize that I cannot answer this more coherently. There's so many variables in your comment, and it would be so hard to really know for sure. I mean, I think the best way to do it would be to take a fixed room. Ideally, this is what I'd want. If I was going to develop this experiment, I'd want two rooms, one that has a decoupled floor and one that has a concrete floor. I then would take and put more subwoofers than are needed for the vibrations in there. So maybe like 618s or something like that for a given room about the size of mine. Everything else would be the same. I would then want to make it so that everything is calibrated properly, levels are matched precisely to within like half a dB. The room should otherwise be identical, like I said, other than the concrete floor and the decoupled floor. Subwoofers are mounted the same, etc. I would then do a bunch of tests, probably with vibration meters, accelerometers, basically, and people. Ask people to go in there, ask them to answer questions based on what they experience, and rate different scenes from different movies that they watch. Probably would get rid of the other speakers even and just have them experience the LFE alone and just comment on what it's like to experience the LFE alone. And basically go through that process so that I could assess the variables that I'm manipulating. The variable that I would manipulate, other than that floor from the 2 rooms, would then be the chairs. So you would pick 4 or 5 chair types, which are clearly constructed differently. You would then put those chairs in the room and have them sit in the chairs. You could probably have all the chairs in the room and just swap them for the center position and have them rate the experience based on the chair they sit in. It's a crossover study because you've got the same set of chairs being used in 2 rooms, which have one thing that's changed in the room. And so it would be the room type times by the chair variable type. And that would give you a set of results where you could look at it and you could see, is it the decoupled floor or not? Or is it, so what you can actually untangle then is the effect not just of the floor and of the chairs, but of the combination of the floor and the chairs as well. And these studies are actually, I used to do these for when I was a researcher, not for chairs, but similar concept. And there's statistical analysis methods you can use to look at that. And I would want to do something like that to try to untangle all of this because there's so much going on here. I just don't have a great answer. All right. Anyway, I hope that this was helpful and that you enjoyed these videos. Subscribe to my channel. Keep on commenting. The donations are very helpful. Please do that. And keep on watching the videos. I got more coming. Thank you.